Chapter 6, we're going to start talking about polynomials. Now, basically, when we were dealing with quadratics before, quadratics are a form of a polynomial. Now, with quadratics, we had the x squared and the x and the constant all grouped together. So with polynomials in general, we're talking about something that has a higher index or a higher degree, a higher power than just an x. Alright, so instead of just limiting ourselves to expressions and equations that just have x squareds in them, we're going to move up a little bit more and talk about what happens when you have x to the third, x to the fourth, different stuff like that. Okay, now objectives are pretty easy here, and this section itself is fairly short, and most everyone should be able to pick up on it fairly easily. Alright, so what we're going to start with here is we're going to identify, evaluate, and then add and also subtract polynomials. So the identifying part and evaluating part, we're more or less going to be kind of giving them names and categorizing them a little bit based on what their powers are or how many terms they happen to have. The last part, classifying and graphing, you're not actually going to have to graph by hand these right now, even though you probably could just by simply filling in values and getting input-output stuff. But we're talking more, once we get above x squared stuff, we talk a little bit more in terms of, graphing calculators are probably your best bet as to how to graph this stuff. But we're just going to look at a couple different graphs of some polynomials, and we're just going to talk a little bit about the different properties or different characteristics those graphs happen to have. Alright, vocab. You'll notice there's a lot of vocab here, and you're going to want to familiarize yourself with these different terms as we go through here. Now on your note guide, you should be able to put some type of definition to go with most of this stuff. Now I'm not going to talk about them right now, but as I go through the lesson, you'll just kind of have to pay attention so you can pick up bits and pieces of what it is that should be written next to each of these terms on your sheet. Okay, so we're going to jump right into this here. Alright, so the first thing we're going to talk about is basically how we can categorize things in terms of how many terms they actually have. Now remember, terms are separated by plus and minus signs, or separated by addition and subtraction. So most of what we dealt with last section with the quadratics, we had trinomials and we had binomials, something that had 3 terms or something that had 2. Okay, we're going to put a little bit more along with this. Now obviously the first term up on top here is monomial. Okay, mono meaning one. So if you just have one term with some exponents and stuff like that, okay, we categorize it as a monomial. Now, monomial, binomial, and trinomial are usually as specific as we get in terms of categorizing by terms. Usually after something has more than 3 terms, we just categorize it as a polynomial. Okay, just in general. Now there are other ways, to categorize if something has 4 terms, 5 terms, 6 terms, something like that. But usually after 3, after we name something a trinomial, if it has more than 3, we usually just say it's a polynomial. Okay, and a polynomial is just going to be a group of monomials. Okay, or a bunch of different terms that have exponents with them. Okay, we just refer to that as a polynomial. Now the important thing to remember is if I just have, like down here on the bottom, if I just have 3x to the 4th like by itself, okay, there's only one term there, so it would be a monomial. Alright, but at the same time, technically, I could categorize it as a polynomial because it is just a term that has some type of exponent with it. Right here, next to it, if I have these 2 terms together, okay, the key being 2 terms, we have exponents involved, okay, we could say we have a binomial. But again, in general terms, you could still say, well, it's just a polynomial as well if you didn't want to be as specific as calling it a binomial. Now on the bottom here, you'll notice there's a bunch of different examples. Okay, these are things that are not polynomials. Alright, you'll notice some square roots in there, some instances where you have variables that are in the exponents, stuff like that. You have an absolute value here in the middle. Okay, those are just examples of things that would not be considered to be polynomials, and we'll get a little bit more specific about that as we go. Now the next thing we can categorize is based on what the degree is of a particular polynomial. Now degree just has to do with the highest exponent that is there. Now categorizing these is a little bit different for monomials as it is for all the rest of the polynomials. If you have a monomial, meaning you have one term, like I have right here, okay, we have to basically add the total number of powers that happen to be there. Okay, well in this case, the one I circled, it's just x to the fourth, so we would say that's a fourth degree monomial. Alright, but as we move forward here a little bit, okay, we want to identify the degree of each of these. Well, the degree of this one up here, we're just looking at the exponent. Alright, it's just z to the sixth, so we would say we have a sixth degree monomial. Okay, so the degree of this one would be 6. Alright, over here, okay, for b, we just have a number. Now remember, if you have a number, or even just a variable by itself, technically it's raised to the first power. So technically we'd have to think about this as being raised to the first power. Alright, if it's raised to the first power, we would just go ahead and say this is a first degree monomial. Okay, down here, again, we're really only worried about the variables that are involved with this. Okay, so technically x is raised to the first, y is raised to the third, so I would have a fourth degree monomial. Over here, alright, b is technically raised to the first, so I just add all those exponents together and this would be a sixth degree monomial. Okay, so really all we're doing is we're just go ahead and adding the particular exponents together if you only have one term. Now again, we'll talk about how this works when we start having polynomials and stuff like that. But with monomials, you take the powers that exist there on your variables, or if you just happen to have a number by itself like this, okay, we would say that's a first degree. Okay, now moving along here. Actually, let me go back here a second. I got to clarify this up here. I was wrong on this one right here. Technically, if you have 5.6, there's no variable behind it. You could assume it's like this, x to the 0, because anything to the 0 is just 1. So technically, because we have no variables here, this would actually be a 0 degree monomial. Okay, because there's no variables involved in it. We don't include exponents, or we would have to assume, like I wrote right here, that if you did have a variable, it would have to be raised to the 0 power. So 0 being the only exponent that actually exists on a variable. Alright, we would go ahead and say this is a 0 degree monomial. Alright, so sorry I had to refresh my memory there a little bit and kind of forgot about how that has to work. So in all the other cases, you just add the exponents on the variables. If you don't have a variable there, it's just a number by itself or just a constant, then what we do is we just say it's a 0 degree monomial. Alright, now as far as polynomials go, and I got a little bit fuzzy down there at the bottom, but hopefully you can still see what's going on here. Okay, degree of a polynomial, okay, where we start having more than one term, is we just go ahead and look to see what the highest power that is there happens to be. Now if you have a term that has more than one variable in it, you would have to go ahead and add those together just like we did. But if you look at the bottom here, we have x to the third, x squared, x, and then just a constant. Alright, so you can see underneath we wrote the degrees of each of those terms. Alright, so if you want to classify the degree of the entire polynomial, you look to see what the highest degree present is. So this would be a third degree polynomial. Okay, and we're just going to call it a polynomial because we have more than 3 terms. Okay, the only other thing would be, remember the numbers that are in front of terms are referred to as coefficients. Alright, the number that is in front of the highest degreed term is referred to as the leading coefficient. Leading just because it comes first. Alright, now I kind of alluded to this a little bit already. Okay, but we can classify polynomials according to the number of terms, and I said most often what we do is if we have one term, we say it's a monomial. If we have 2, we say it's a binomial, and 3 is trinomial. And after that, what we do is we go ahead and we basically just say polynomial. Now, the other thing we can do is we can classify by its degree. Okay, if you just have a number by itself, it's referred to as a constant. Okay, if it's linear, or we just have like x minus something or x plus something, it's referred to as linear. All right, then what we dealt with last section or last chapter a lot was something that's quadratic. Your highest degree is 2. Okay, we had a lot of x squared stuff. So we refer to those as quadratic, expressions, quadratic equations. There are names for things that have powers that are higher than 2. A power of 3 or a highest degree of 3 would be a cubic function. Power of 4 would be a quartic function, and a power of 5 would be a quintic function. Now, these last two here, a lot of times those names don't get used a whole lot. It's okay, to put them up there, obviously, and to remember what they are, but most times after cubic, again, we just start referring to things as polynomials. So if it has a power of 4, most times you would just say, it's a 4th degree polynomial. You don't usually hear people very often say, oh, I have a quartic function or I have a quintic function. Okay? Now, the next thing we're going to do here is we're just going to classify these a little bit. Okay, so we want to rewrite these in standard form. Remember, standard form is just starting with the highest degree and working your way on down, or the highest power and working your way down. So this first one here, go negative 5x squared plus 4x plus 3. Okay, just writing it in standard form. And I'll do the same thing with the one on the right here. 8x to the 4th plus 3x squared minus 4. Okay, so then we want to identify the leading coefficient, the degree, and then the number of terms it has, and then we're going to go ahead and name the polynomial. Okay, so we'll just name it as best we can here. So in both cases, the leading coefficient is just the number that comes in front of the highest degree. So on the left, it's negative 5. On the right, it's 8. Okay, as far as degree is concerned, this would be a 2nd degree polynomial. This would be a 4th degree polynomial. All right. Number of terms. In both cases, we have 3 terms. Okay, so 3 terms here, 3 terms over here. All right, now the last thing says name the polynomial. Okay, there's a lot of different ways you could go with this. Okay, so on the left here, we already said we could say a 2nd degree trinomial. We could also refer to it as a quadratic expression. Quadratic because the highest power is 2. Quadratic trinomial. All right, a lot of different options you could do on that one. On the right over here, okay, we could say 4th degree trinomial. You could say you have a quartic function or a quartic expression. Quartic because the highest power is 4. You have a quartic polynomial, you have a quartic trinomial, so you can see how there's a lot of different directions that you can go with these. Okay, so for the most part, I would focus with these on the degree, and trying to be able to classify in terms of terms if you have 3 or less, trinomial, binomial, monomial. If you have more than 3 terms, we can refer to everything as a polynomial then. And then try to focus on some of those specific names. Is it quadratic? Is it cubic? Is it quartic? Is it quintic? All right, and also be able to understand how those relate to the different degrees. Okay, 2nd degree is quadratic, 3rd degree cubic, 4th degree quartic, and so on down the line. All right, now the next thing is we're going to just add these together. Now, really all adding and subtracting is a matter of combining like terms. Now, there's a couple different ways you can do this. You can just look at what's given to you, like I have right here, and we can go ahead and just combine like terms. So anything that's x to the 3rd goes with x to the 3rd. Anything that's x squared goes with x squared. Constants go with constants. Linear terms, or just x terms, go with x terms. The other thing that some people talk about is they'll actually write these out vertically. So we have an x to the 3rd, we have a minus x, and we have a plus 9. So I kind of left a space there where and I can actually write it in like this. We don't have an x squared term, but I'll write it in as 0x squared just to line things up. and then we have an x to the third, we have a 5x squared, we have a 7x, and we have a 4. So they'll line them up like that, and they'll basically say, okay, I'll have 3x to the third plus 5x squared plus 6x plus 13, and add them together. Now, I'll be honest with you, I don't do it that way. I usually just look at the top and say, all right, I'm going to put x to the thirds with x to the thirds. I'm going to put constants together. I'm going to put linear terms together, and I'm just going to go from there. I think when you start lining things up vertically, it can be a little bit confusing. Okay, but I showed you both ways because sometimes it tends to, people enjoy, would rather see things, I guess, from a spatial perspective lined up over the top of each other. Now with something like this, where we're subtracting, thing with subtracting, just like we did before, always change your subtraction to addition and add the opposite of everything. Alright, now I'm not going to line these up vertically, I'm just going to go ahead and combine. So I know I can put these two together. So negative 2x squared minus x squared would be negative 3x squared. Alright, I don't have another x term, so I'm just going to put plus x, and then I can put the constants together. 3 plus negative 6 would be negative 3. Alright, so when I subtract those, that's what I get. Alright, make sure you write your answers always in standard form, highest degree term first. Okay, and if we want to think about this in terms of how we were categorizing things before, we could say this is a quadratic trinomial. You could even say it's in general a polynomial, second degree polynomial, second degree trinomial. Again, lots of different ways you could go with that. Okay, now you are going to have a couple, story problems as far as these goes, and these are pretty straightforward. And I would expect that you'd be able to do these without a whole lot of problems. Okay, so in this case here, we're given a function that represents the cost of producing a certain product, where x is the number of units, okay, in hundreds. Evaluate f of 0 and f of 200 and describe what the values represent. So this is pretty basic, back to what we did when we first started talking about functions. F of 0, so third, sorry. F of 0 just means I'm going to fill 0 in wherever there happens to be an x. Now in this case here, these first two terms or spots become 0. I end up with 45. Okay, so the cost of manufacturing a certain product. So basically, if we produce 0 units, okay, it's still going to cost us, we came with a 45, and it says up here it's the value in hundreds. So basically, we would have to add a couple zeros into that, but it's still going to cost us $4,500, basically kind of like a flat rate or something to produce these, whether or not we produce any items at all. Alright, then f of 200, this one's going to be a little bit bigger, obviously, times 200 plus 45. Okay, well, 200 raised to the third times 3 is a rather large number. 24, 1, 2, 3, 4, 5, 6 zeros behind it. Minus, you got 18 times 200 minus 3,600 plus 45. Okay, so if you go ahead and you take 24, 1, 2, 3, 4, 5, 6 zeros behind it, minus 3,600 plus 45, you get a really big number. 996,445. Now remember, it's in hundreds, so I'd have to add 2 more spaces to it. So we got lots going on there. It looks like about 2 billion, a little over 2 billion, almost 2.4 billion dollars. 2.4 billion that we would end up getting off of that. Okay, so again, just kind of look at what's going on here as far as explaining what the values represent. All right, we're given a cost function where x is the number of units of the product in hundreds. Okay, So basically, when we're looking at f of 0, pretty much means we're not, producing much of anything, but we still have that 4,500 because, you have that extra 100 that has to go through there. The end 200, again, if it's representing things in terms of hundreds, you have 200, you fill that in, you just add a couple zeros to the end of what you got going on at the end because it's actually representing hundreds of products, not just 200. Okay, so the number of products, number of units in hundreds. All right, so again, just as far as explaining what's going on, you have a product, you fill it into the function, you get a cost coming out of the function. All right, now the last thing here when we wrap up is we're going to talk about graphs and looking at what happens when we have higher degree polynomials. Okay, so if we look at this, I already have the graphs up here for you, and we'll talk a little bit in class about how we're going to graph these. But what we're really looking for is zeros, if we're going to have any real zeros, meaning points where we cross the x-axis, and just where's the function happen to be increasing or decreasing. So if you look over here at this cubic function, okay, this cubic polynomial, you can see it looks like we're going to have 3 places where we cross the x-axis, meaning we'd have 3 zeros or 3 roots to that particular function. Now, it's a little difficult to be able to tell right here, all right, what we're basically looking at, okay? But, you'd probably have to use the calculator or something like that to be able to identify those a little bit better, because factoring and all that stuff doesn't necessarily work real well with these higher order polynomials. The other thing is being able to identify where the function is increasing or where it is decreasing. So if you look right here, we would be increasing all the way to about here. So whatever this x value down here would be where we stop increasing. And from that x value to here, okay, this section in the middle, we would be decreasing. All right, and at the very end, from whatever this x value is, we would be going up and increasing. So that's kind of how we want to be reading graphs. Where is it increasing? Where is it decreasing? Okay, because we think about a lot of these functions in terms of like the last problem you had, they're cost functions. All right, so when are we gaining money? When are we losing money? All right, this one on the right probably looks a little more familiar to you. Okay, doesn't look like you have any real zeros because you don't intersect the x-axis anywhere, meaning you're probably going to have imaginary roots. All right, and again, right here kind of looks like the middle as far as if you were to take it down as far as an x value. So you'd be decreasing to here, but then you'd be increasing on the other side up. Again, some type of function where you'd like to know one way or the other where you're increasing or decreasing. All right, here's just another example, and you can kind of see what's going on with these as well. On the left, you're going to have 2 real zeros. On the right, you're going to have, looks like 4 of them over there. And increasing and decreasing would work in a similar fashion. Other things we can talk about with some of these quartic and quadratic functions is, do they open up, do they open down, so on and so forth. What does that actually mean for us? Okay, so that kind of summarizes all that stuff that I wanted to get out of that. Again, hopefully this should be a relatively easy section to kind of get us started as far as, we're just going to do some naming, categorizing, and then adding and subtracting. And the story problems, like I said before, are pretty straightforward as far as what we're trying to accomplish with those. Okay. Again, if you have any questions, please make sure you ask. All right.